Let's take a look at the last question on your test. It's the application of Quadratic's question. So we have a stunt car, and its path is modeled by an equation where h is the height of the car above the ground, d is the horizontal distance from the ramp. So those are important things to know. Right, here we go. It's important to know what the variables represent. And I've asked you to use the equation to answer the questions, and the graph is to kind of help you out to check your answers. Okay? So how high is the ramp? All right, well, where does the car take off? You might think the horizontal distance from the ramp, where the car is taking off, should be 0, right? So d is 0. So you could do two things. You could either plug 0 in here and calculate what the height should be, or you can look at, we're going to be looking at what this point is down here, and that is the y-intercept. So we're actually looking for the y-int. Where something starts is usually the y-intercept, and that number is right there. That's what you'll get when you plug in 0 anyway. So that the ramp is 3.6 meters high. Okay. How far, so we're done that one. How far from the ramp will the car land? So you might look at this and say, okay, it's going to land right there. So you might answer 9 meters right away. It looks pretty definite from the graph. What part of the graph are you looking for? You're looking for the second x-intercept. And how do you calculate the answer? Well, if I wasn't given a graph at all, I'd have to examine my equation, so h equals -0.1, and I have to actually factor it because you need to find the x-intercepts, and to find them, the only way we know to find them is to find the x-intercept. So I'm going to factor out -0.1, so I get b squared, divide everything by -0.1, I get -5d and -36. This is not fully factored yet, right? I only have, I still have a trinomial in this bracket here. So I can factor that yet, leave the -0.1 out in front. What adds to -5 and multiplies to -36? -9 and +4. Now, I can check, and this is what I was hoping you'd do, is check with the graph. So we have 9 here, that comes from the first bracket, and -4, which comes from the second bracket. So I've factored correctly. Alright, now how far from the ramp is the car when it's highest? So I'm looking for how far, so somewhere here, right? How far when it's highest? I'm looking for the x value of the vertex. Okay, if you said vertex, it's not a big deal, but I'm looking for halfway in between -4 and 9, and they give you a little hint here. To find the middle of two numbers, add and then divide by 2. So I want 9 plus -4, that's 5, and now I want to divide 5 by 2. So 2.5, and that looks about right from the graph too. And so 2.5 meters is how far the car is when it is highest. And of course, with that I ask, how high does the car go? Now I'm looking for a height, a y value. So I'm looking for the y value, not the y-int, but the y value of the vertex, the second number. Okay, so that's right up here somewhere, and I know it's a little bit more than 4, and you can calculate it. You plug -2.5 into your equation. So we have this equation here. Okay, we're going to have to plug in 2.5 twice, and I'm going to assume that you can do the rest. Okay, and then you give your answer in meters, so it'll be a little bit more than 4. Okay, that's how to be accurate.